Continuing with our trig identities and equations unit, we are going to focus this lesson on the subtraction and addition compound angle formulas. These are on your formula sheet, so make sure you have your formula sheet in front of you so when I refer to them, you kind of know what I'm referring to. Our learning goals, normally it'd be memorized. If we were in class, you wouldn't get the formula sheet, but obviously you have that as a reference for you right now. So really, you just have to memorize how to use the compound angle formulas and really what it means. So that brings us to what is a compound angle? Well, a compound angle is any angle that is created by adding or subtracting two or more angles. You're going to notice it's bold and underlined two. We're going to focus only on what happens when you add or subtract two angles and not more than two. It gets much fuzzier and more complicated when that happens. Now there's a big difference here. So I have kind of a counter example or what not to do to start here. Sine 75 does not equal sine 30 plus sine 45. And to prove that to you, just take out your calculator. Make sure you're in degree mode, since those are in degrees, those aren't radians. Sine 75 is 0.966, I believe. Sine 30 is 0.5. Sine 45 is roughly 0.707. Okay. If I add those together, I get 1.207. Left side clearly does not equal the right side. That is not a true statement. So when we're talking about adding or subtracting, we're not talking about adding or subtracting trig ratios. We're talking about adding the angles. So instead, try this. Sine 30 plus 45 in brackets. Now, you could enter it like that, or obviously, according to Bedmas, you have to do brackets, right? 30 plus 45, 75, sine 75. Calculator tells us 0.966. These two things are definitely equal. And that's kind of where we're going with this. And again, we're not going to do any proofs for these. We're skipping the proofs for the virtual learning. Again, you have the formulas in front of you. Now, there are some key numbers you are looking for that have nice ratios because you're going to be asked to find an exact solution for the vast majority of these. If the question is in degrees, you are looking for these numbers: 30, 45, 60, 90, 180, 270, 360. And then, even though I didn't list them, basically any multiple of 30, 45, or 60 there in between is going to work as well. We would just have to use the Cartesian plane. When we're talking about radians, just another way to measure an angle, right? It's more confusing, or often found more challenging, because most of you probably dislike fractions. And when it comes to radians and talking about pi, you're going to have to deal with fractions. So you're looking for things that are pi by 6s, pi by 4s, pi by 3s, pi by 2s, pi's, 3 pi by 2s, and 2 pi's. Just like for the degrees, even though I didn't list them all, basically anything that has a common denominator of 6, 4, or 3, or 2 is going to work. You're just going to have to do the Cartesian plane. It's not just going to be in quadrant 1 or where they are all positive. So the hardest part about this is working with radians and figuring out what two fractions to add or subtract. getting to our first example, we want to determine the exact value So we want the exact value, meaning no decimals, of sine 75. Now sine 75, that's not a special triangle, but as we just examined in our little investigation earlier, you could do 30 plus 45, and we have nice special angles and triangles that have exact solutions to them for 30 and 45. So you are going to look at your addition compound formula for sine. So I'm not going to bother writing out the formula like sine A plus B is sine A cos B plus cos A sine A. I'm not going to bother writing that out because you have it in front of you. I'm just going to go right to what your first line after the formula should look like. So we're changing sine 75 to 30 plus 45. That's your A, that's your B. So following the format of our formula, sine A cos B, sine 30 cos 45, plus cos A sine B, cos 30 sine 45. Now, some of you I know have special calculators that you wouldn't normally be able to use in class. So virtually for your test, you do have to show me how you get all of these exact values. And how do you show me? You just recreate those special triangles. So you just draw them for me. So 30, 60, 90, right? 2, 1, root 3. And the 45, 45, 90 triangle, which is 1, 1, root 2. I need to see those for every single solution so I know where you're pulling the information from. Sine 30, opposite over hypotenuse, 1 over 2. Cos 45 would be 1 over root 2. I'm going to cut to the chase here. Can't have roots in the denominator, so root 2 over 2. Cos 30, adjacent over hypotenuse, root 3 over 2. And sine 45, opposite over hypotenuse in the 45-degree triangle, 1 over root 2, which is root 2 over 2. Now you just got to multiply root 2 over 4 plus root 6 over 4. And that gives us root 2 plus root 6 all over a common denominator of 4. That is your exact solution. That's what I'm expecting to see. You could always check your answer. You could type in root 6 plus root 2 divided by 4 into your calculator. Then type in sine 75. That decimal should be exactly the same. In fact, we know what it is. It's supposed to be 0.966 when you round. Next example, determine the exact value of cos 15. Again, the trickiest part about this is you figuring out which angles to either add or subtract to get 15, and they have to be one of those special ones. And there's sometimes more than one combination that will work. Maybe you're thinking 45 minus 30. That's certainly 15, right? So then we're going to use our cos subtraction formula, compound, which is cos 45, right? Cos A cos B plus sine A sine B. So cos 45 sine, oops, got ahead of myself there. Cos 45 cos 30. And then plus sine 45 sine 30. Now to save time, because you have the special triangles hopefully copied out in front of you by now, to save time, I'm not going to bother writing those triangles here. You can refer to them. Again, to warn you, for your test, you need to draw those special triangles every single time so I know where you're getting the solution from. Cos 45, root 2 over 2. Again, we don't want radicals in the denominator. cos 30 root 3 over 2, sine 45 root 2 over 2, sine 30 1/2, doing some multiplying, root 6 over 4 plus root 2 over 4. That ends up being root 6 plus root 2 all over a common denominator of 4. No, all the answers are not always going to be in terms of root 6s and root 2s. But you are going to see a lot of these numbers repeat over time just because you're only dealing with 1s, 2s, and root 3s. That's it, right? Again, you could check your answer by typing in that expression and then typing in cos 15. The decimals, the approximated answers will be the same if you've done your work correctly. 1c, determine the exact value of cos 11 pi over 12. So now that we have the hang of what we're doing, we're going to pick it up a notch here. It's radians, means it's going to have to be fractions. Okay, so I know that for sure it's going to have to be cos, right? Because it's cos 11 pi over 12. The more practice you get with these, the more readily the answers might come to you, or quicker they might come to you. But what I like to do is, okay, we know we have to have a common denominator of 12. Okay. And start thinking of numbers that add to 12, or add to 11, sorry. So you could try 10 and 1. Yes, that adds to 11, but 1 over 12 is not one of our special triangles. You could try 6 and 5. You could try 2 and 9, so on and so forth. Waiting to see if when you reduce, you get some of those special angles. To cut to the chase, if I were to do 8 plus 3, that's 11, okay? And if I reduce 8 pi over 12, divide everything by 4, I get 2 pi over 3. Now that's not one of my special angles, but it does have 3 as the common denominator, which means I can actually use my special triangles, but in the Cartesian plane. Similar to last unit with special angles. And 3 pi over 12, well, that reduces if I divide by 3 to pi over 4, which is definitely a special angle. So I can change cos 11 pi over 12 into an addition compound angle formula. 2 pi over 3 plus pi over 4. Then just following the format, right? Cos A cos B minus sine A sine B. So cos 2 pi over 3, cos pi over 4 minus sine 2 pi over 3 and sine pi over 4. Cos 2 pi over 3, you're going to have to do some work for that. Cartesian plane, where is 2 pi over 3? Well, it's over here. So this is why it's important that you have the last unit skills locked down here. Right, so that's 2 pi over 3. What's left over as your related acute angle? Pi over 3. Obviously, that's our special triangle. Pi over 3. Across from it is root 3. Hypotenuse is 2. Down here is 1. So cos 2 pi over 3, right, adjacent over hypotenuse, or if you prescribe to the circumference, x over r, we end up with 1/2. However, do not forget, only sine is positive in that quadrant. So cos 2 pi over 3 is actually negative 1/2. Cos pi over 4, that's in quadrant 1. That's one of our special triangles. For a test, you would write it down. I'm not going to bother right now. Root 2 over 2. Sine 2 pi over 3, opposite over hypotenuse, or y over r, root 3 over 2. And it's in the positive sign quadrant, so we don't have to make it negative. Sine pi over 4, root 2 over 2. Now you're just left with doing some multiplying. Negative root 2 over 4 minus root 6 over 4. Negative root 2 minus root 6, all over a common denominator of 4. And there we have our exact value, our exact solution to cos 11 pi over 12. I can't stress this enough. You can check your answer. Type in that exact solution, negative root 2 minus root 6 over 4. Type in cos 11 pi over 12. Make sure you've converted your calculator back to radians, though. Unless you want to convert that to 11 times 180 divided by 12 and keep it in degrees, whatever. The decimal should be exactly the same. Our next example, so we're kicking it up a notch again. Determine the exact value of tan 5 pi over 12. Now this is kicking it up because the tan formula is complicated. Now if you're going to ask me, well, I know tan is sine over cos, could I do the sine formula over the cos formula? The answer is yes, but it's it is, I wouldn't necessarily say it's less complicated, but sometimes that's people's preference. But I'm going to stick with tan. So again, if we're trying to figure out what to do here, we know we need a common denominator of 12. You could try 1 and 4. 4 over 12 is going to reduce, but 1 over 12 is not a good number for us. It's not one of our special ones. Let's try 3 and 12. 3 and 2. 3 plus 2 is definitely 5. Do these reduce? Yes. Divide that by 3. We get pi over 4. And divide 2 pi over 12. You get, divide everything by 2, pi over 6. Perfect. So tan 5 pi over 12, we can make it a compound addition formula for tan. Pi over 4 plus pi over 6. And then we got to sub it into that beast tan formula. So tan pi over 4. And don't forget, this is like your A, this is like your B. Tan pi over 4 plus tan pi over 6. All over 1 minus tan pi over 4, tan pi over 6. Tan pi over 4, that is just 1. Opposite over adjacent. Again, for your solutions, you'll draw the triangles. Pi over 6 is 1 over root 3. Okay. I'm going to make that not have the radical in the denominator, which means it will be root 3 over 3. So plus root 3 over 3. All over 1 minus tan pi over 4 is 1. Tan pi over 6 is root 3 over 3. That more or less was the easy part. Now the tough part is going to be simplifying radicals with fractions. I need a common denominator. So on top, I have 1 plus root 3 over 3. My common denominator would be 3. So really, this is 3 over 3, right? Changing the 1 to root 3 over 3. And then same thing on the bottom, right? It's going to be 3 over 3 minus root 3 over 3. Now that I have a common denominator, I have 3 plus root 3 over 3 all over 3 minus root 3 over 3. Okay, this is weird. We're going to have to work with this a little bit, simplify. So I'm going to continue this up here. When you are dividing fractions, you have to remember, what do? Invert and multiply. So you change your divide symbol. So we have 3 plus root 3 over 3 on top. Then we have the fraction line, which really means divide. Change that to a multiply, and then invert. Flip the second fraction. So 3 over 3 minus root 3. Now something good happens here. The 3's cancel. Do not cancel anything else out. They're separated by pluses, minuses. That would be a cardinal sin. 3 plus root 3 all over 3 minus root 3. That is also problematic because in math, we can't have radicals in the denominator, or at least it's bad form. Going back to your favorite grade 11 unit, simplifying radicals and rationals, you have to multiply by the conjugate, if you remember. So that's 3 plus root 3 over 3 plus root 3. So the conjugate just means opposite. So on the bottom, I got 3 minus root 3. The conjugate is the opposite, 3 plus root 3. So now you foil the top and you foil the bottom. Now when you do that, again, you show all your steps. I'm running out of room here. So when you foil, you should get 9 plus 6 root 3 plus 3 on top. And on the bottom, the middle term should cancel. And you should be left with 9 minus 3. Collecting like terms on top, 9 plus 3 is 12. Plus 6 root 3 all over 6. And we have one more thing we can do. We can get rid of that 6 on the bottom by dividing every term on top by 6. So that would give us 2 plus root 3 final answer. Whew. Definitely with the tans, there's going to be a lot of simplifying and a lot of radical work you're going to have to work around, or at least get comfortable with. Example 2. We want to simplify each. This is a little bit switch of gears here. Instead of you expanding the compound formula, I'm giving you the compound formula and you got to work backwards. So we have to identify the pattern. So if you look at 2a, it goes cos cos plus sine sine. Well, hopefully you identify that as being the compound angle formula for cos and subtracting. And that would be your a and that would be your b. So we can simplify this to cos 7 pi over 12 minus 5 pi over 12. 7 minus 5 is 2. So cos 2 pi over 12. And that reduces to cos pi over 6, which we have a special triangle for that. Again, in your solutions, make sure you draw it, but I'm just going to give you the answer. You're looking at the special triangles. That ends up being root 3 over 2. What about the next one? Sine 2x cos x minus sine 2x cos 2x sine x. Well, hopefully you identify that as the compound angle formula for sine, but subtraction. That's like your a, that's like your b. Sine 2x minus x. What's 2x minus x? Sine x. There's nothing else we can do with that. That's just showing you, it doesn't always have to be radians or degrees. It could just be plain letters or variables, and you have to simplify. Our third and final example. We are going to evaluate sine a plus b, where a and b are in quadrant 2, and sine a equals 3/5, sine b equals 5 over 13. I like questions like this. It forces you to come up with a plan and do some things. Where would I start if I were you? Well, it's compound angle formula addition for sine, so let's start there. Sine a plus b. This time maybe we'll write the formula. Sine a cos b plus cos a sine b. You actually can start filling in some answers right now. Sine a, I told you, is 3/5. So that's that. Now before moving on, I want to point you to a very common mistake. A common mistake is somebody's going to tell me sine a equals 3/5, and they're going to write that in. Like write that there, sine a equals 3/5, or sine of 3/5. That's going to lead you down dark, never-ending, no chance for escape, dark, dark, dark alley that you'll never make it out of. Sine a equals 3/5. That means that whole thing equals 3/5. Just replace it with the fraction 3/5. Don't include sine, don't include cos. Cos b, I don't know. Sine b, or cos a, I don't know. Sine b, I do know. 5 over 13. So step number 1. We have to come up with cos b and cos a. Doesn't matter what order you do these in. Since a comes first in the alphabet, I guess I'll do that one. So this is for triangle A. Now it tells you that they're both in quadrant 2, so that's over here, right? cast, which that makes sense. Both the sine values were positive, so that's good. So if I'm in the A triangle, right, there's our little related acute angle. Opposite over hypotenuse, 3 over 5. Now, I'm not going to bother doing the Pythagorean theorem here. It's pretty straightforward. For a test, make sure you show me that work. 5 squared minus 3 squared, right? 25 minus 9, 16 square root, that is 4. So from there, I can now calculate cos A. 4 over 5, and since it's in the sine quadrant, negative. Negative 4 over 5. Now let's do it again, but for the B. So this is the B triangle, or B angle. There's our little related acute angle. Sine B is 5 over 13, opposite over hypotenuse, right? Make sure you show your Pythagorean work here, but 169 minus 25, 144 gives us 12. That means cos B is adjacent over hypotenuse, 12 over 13, and it's negative since it's in the sine quadrant. Now to go about your business, you literally could, like, and this is be perfectly fine for a test. Once I see all of this, that is just, oh, don't forget about the plus sign in between. That's literally just calculator work. You can enter it just like you see it, brackets, plus sign, negative sign, and you should get negative 56 over 65. Now I will warn you, if you're not comfortable with that, or you would like to show as many steps as possible, as I've always encouraged you, that's a good idea to try to get as many part marks in case you make a mistake. So even though I cut to the chase here with the final answer, you're more than welcome to show me all the steps. And in fact, it's probably a good thing just in case you make a simple mistake, I can give you way more part marks. That is it for your lesson on compound angle formulas. Not too bad once you start practicing them. Make sure you know how to do a question like that last question that we just did. As always, check D2L for the actual work in case I've changed it. If you have any questions, be sure to let me know. By the time you're listening to this, I hope you've had a good long weekend, and we're almost there. We're almost there. Happy mathing, everyone. Thanks for listening.